Hello students. In this video we are going to discuss the relationship between multiplication and division. We are going to learn to remember math facts, both multiplication and division, by using patterns and relationships. So that's our I can statement. Remember that I told you in the last video and in previous lessons that multiplication and division are inverse operations. Inverse operations. So you use one to check your answer for the other. So multiplication and division are inverse operations, and addition and subtraction are inverse operations. They are operations that go together and are the reverse of each other. When we talk about patterns in multiplication, some of the common patterns that we remember are our 9 patterns. So for example, if you put 0, 1, 2, 3, and 4, and then you came back and started with your highest digit in the decimal system, 9, and went backwards, 8, 7, 6, 5, you would have the first 5 multiples of 9, because there's a pattern that follows in the 9 math facts. It's always one less each time. So you can always add up the digits and they will always equal 9. So the tens place and the ones place added up equal 9. 1 plus 8 is 9. 2 plus 7 is 9. 3 plus 6 is 9. 4 plus 5 is 9. There's also a hand pattern that you can use. It's hard to show on video, but we can teach you in class on how to remember patterns for your 9s. Let's talk about patterns in division. Let's make a little division symbol. Let's look at the 11 patterns. But let's do it from a division standpoint, getting less and less. I picked 11 because it's very easy. We can start with 99, then go to 88, and then 77, 66, 55, 44, and so on. That is a division pattern that we notice where the digits are the same. Every time we subtract 11, we get one less in each place value, because we're taking away a 10 and we're taking away a 1 each time. So those are some patterns we already know. We talked about it in the first lesson, lesson 1 for topic 4, but we're going to talk about it again. Family facts. I'm sorry, here I'm dyslexic. Okay, fact families. So a fact family is a group of related number sets. And as an example, some people think that 8 times 7 is one of the harder math facts to remember. But if you learn it in a particular pattern, it makes it very easy for you. For example, let's count 5, 6, 7, 8. 56 is equal to 7 times 8. Once we remember this fact, we can get all the other fact families that go with this and have it correct. So it's easy to remember that 56 is the answer to 7 times 8. Let's add our other fact families. 56 equals 8 times 7. 56 divided by 8 equals 7. And 56 divided by 7 equals 8. Another thing that you'll need to be really working hard on right now is your 60-second sweep. because that is learning speed and accuracy for your fact families or your number sets. And the only way to get better and faster once you have your accuracy down is to increase your speed by practicing, practicing, practicing. Very, very important. I'm going to pause now so that you can catch up with these notes. Okay, I'm going to go to a new page. You can continue from where you are with your notes. Let's look at another way that we can identify relationships. Let's put a symbol instead of a number. This triangle is equal to 3 times 7. Okay. Is this triangle equal to A, 21, B, 10, C, 18, or D, 4? Most of us can identify quickly that is a math fact, and 3 times 7 is 21. What if we have two symbols? Let's say we have a circle and a triangle. And the circle and the triangle are equal to 12. Okay? If the circle equals 3, then what is the triangle? Or what does the triangle equal? Well, 3 times some number is equal to 12. And we know that that number, or in this case the triangle, is equal to 4. Because 3 times 4 is equal to 12. Sometimes you're going to actually have a table with patterns and relationships. So let's say we have a star symbol and a square symbol. And I have a 4 and a 12, a 6 and an 18, an 8 and a 24. Well, what if I put a question mark here? I wanted to find out the next number. You could probably identify, just by the practice we've done with tables, what this pattern is and figure out this number. Let's write it in a symbolic form. Let's say we have our star times some number is going to give us our square. So if our square is 30 and our star we don't know, then we have to identify what the pattern is to find out what goes here. So the pattern in each one of these is times 3. 4 times 3 is 12, 6 times 3 is 18, 8 times 3 is 24. So I would plug that 3 into my pattern, and I'm looking for an answer of 30. What number would that star be? Well, knowing our math facts, we know that star is 10. So 10 times 3 equals 30. Another way to look at a problem would be, what number makes this sentence true? This is one of those problems you'll see pretty often on the test. let's say we have 100 divided by some number is equal to 25. Okay. Now, is the triangle equal to A, 10, B, 250, C, 4, or D, 25? Think about it in terms of money. If you have 100 pennies and you split them up, how many groups would you have if you had 25 pennies in each group? Now, from working with money, we should know. We can't really figure it out yet by using long division. We need long division at this point, but we know in our heads that 4 quarters is equal to $1. 25 pennies 4 times is equal to 100 pennies. So the triangle is equal to 4 because 100 divided by 4 equals 25. I'm going to, this is the end of the video, so you can go ahead and pause it to write all of this information. And tomorrow in class, we will do multiple examples of identifying patterns using division and then using symbols in our division problems to figure out the answers and to solve them. I hope you have a great afternoon. See you at school in the morning. Bye.